First, let's determine the corresponding h for this values of x equal to 4 and y equal to 3. For this, I'm going to apply the Pythagorean theorem to the rectangle. This is applied because we know that each of the interior angles of a rectangle is 90 degree. So I have just marked 90 degree over here, and this means these two sides, that is with the lengths x and y, are the two legs, and the side with the length z is the hypotenuse of the right triangle formed inside the rectangle. So we can apply the Pythagorean theorem, which says that sum of the squares of the sides is equal to the square of the hypotenuse, which means I can write this as sum of the squares of the sides. One of the side is x, so I write down as x squared, plus the another side is y, so I take the square, and this is equal to square of the hypotenuse. Z is the side length of the hypotenuse, so I write down this as z squared. Now I'm going to differentiate both sides with respect to time. So I write down this symbol d by dt of this quantity, and also for the z squared I find the derivative, that is d by dt of z squared. Now let's apply the power rule as well as the chain rule to differentiate the x squared plus y squared as well as the z squared. So this could be written as d by dt of x squared when we use the sum rule of differentiation, plus d by dt of y squared equals d by dt of, that is the derivative of z squared. Now let's apply the power rule first. So derivative of x squared is 2x times of dx over dt when we apply the chain rule. And similarly, derivative of y squared is first apply the power rule. So we get y and then multiply with the derivative of y with respect to time, which is dy over dt. And this is equal to, similarly, this will also be 2z times of dz over dt. Now we know that x equal to 4 and y equal to 3, but we want to find the corresponding z. So once again we apply the Pythagorean identity or the theorem, so which says that x squared plus y squared equal to z squared. So I mark 4 for the x and 3 for the 3 for the y. Then I want to find the z. So z is basically, if you use the Pythagorean theorem, this is 4 squared plus 3 squared under the root. So this gives 4 squared is 16, 3 squared is 9. So 16 plus 9 is 25. We take the square root of 25, it is 5. So at this instant, we know the value of z equal to 5. So I'm going to substitute all this information as well as the given equations to find the value of k. So I'm going to plug in x equal to 4. Before I do that, I can see that I have all 2 in each of the factors. So I'm going to cancel those 2's. I have this 2, I have this 2 as well as this 2. So I cancel all of them. Let me rewrite without the 2's. So basically we have x times of dx over dt plus y times of dy over dt equals z times of dz over dt. We know the values of x, y, and z as 4, 3. So here we substitute 4, and here we substitute 3, and for z we substitute 5. It's 5. And we are also given the some equations. Dx over dt, we can replace this as dz over dt. So this becomes 4 times of dz over dt plus 3 times of dy over dt is given as k times of dz over dt. So I put k times of dz over dt, and this gives z is 5 times of dz over dt. So now we have the equation, everything in terms of the unknown dz over dt. In fact, these two are like terms, that is 4 times of dz over dt plus 3 times of k 3k times of dz over dt. We can combine this and write down this as dz over dt times of 4 plus 3k. This is equal to 5 times of dz over dt. Now we cancel, or if we divide both sides by dz over dt, this dz over dt will get cancelled. So finally we end up with the equation 4 plus 3k equals 5. We subtract 4 from both sides, so we get 3k equal to 5 minus of 4, which is 1. And we divide both sides by 3, so we get k equals 1 by 3. So this is the value of k.